Hi, and welcome to Exercise 4 of our Environmental QGIS for Beginners course. To begin, open up the Exercise 4 workspace provided. In your Training Data folder, locate 01 Training Data, 00 Workspaces, and open Exercise 4 Gaia, and save to your working folders under 02 Training Outputs, 00 Workspaces as exercise4.qgs. We've supplied you with a Microsoft Excel sheet for this training, which can be found under the 01 Training Data, 02 Excel folder. So in Microsoft Excel, open the file weedpoints.xls. Don't change any of the values at this point, just take a look at the layout of the data. And save a new copy of the file in your 02 Excel folder in a CSV format. This is the format used to import locations into QGIS. In Microsoft Excel, click Save As. Choose the Save as Type option as CSV, delimited.csv. This setup might be slightly different depending on the version of software you're using, but don't stress. Name the file weedpoints.csv and save in the folder 02 Training Outputs, 02 Excel, and click Save. If a message window appears, click Yes, then close Microsoft Excel. If a message asks you if you'd like to save your changes, click Don't Save. In your QGIS workspace, click on the Add Delimited Text Layer icon on the left side toolbar. That's this one here. And in the Create a Layer from a Delimited Text File section, amend the following details. For file name, browse for the CSV you just created and click Open. For layer name, type weedpoints.csv. File format is going to be CSV, separated values, so ensure that's activated. For record options, ensure number of header lines to discard is 0. To understand what this means, enter a value and see what happens to the table preview. Ensure first record has field names is activated. Check this on and off and see what happens to the table preview. For field options, ensure trim fields is activated. This removes unwanted spaces before and after values. And for geometry definition, let's ensure point coordinates is activated. The X field has the field value easting and the Y field has the field value northing. And click OK. You should now be prompted to select the CRS for your CSV layer, and we want to select GDA 94/MGA zone 50 and click OK. Note, when creating a shapefile from a CSV, remember that there's a 9-character limitation to field names, so names with longer characters will be truncated. The weedpoint CSV layer will now be visible in your table of contents, so activate it to see how it looks in your map canvas. Open the weedpoint CSV attribute table to check that all the attributes converted across OK. Although the points are now visible in the map, we'd like to save them in a shapefile format. The shapefile format allows us to edit and amend the data within QGIS. So right-click your weedpoint CSV layer in the table of contents and click Save As, then change the format to Esri Shapefile and save it to the 02 Training Outputs, 01 Shapefiles folder. For file name, let's go weedpoints.shp. And the CRS, we're going to choose GDA 94/MGA zone 50. If your CRS is different, change the CRS from Layer CRS to Selected CRS and browse for GDA 94/MGA zone 50. Then activate Add Saved File to Map and click OK. Your weedpoints layer should now be visible in the table of contents. Ensure it's activated and located at the top of the layer list and rename it to weedpoints. As we won't need the CSV file anymore, remove the weedpoint CSV layer from your table of contents. Now we're going to symbolize the data. Style the layer using categories to show the different species. Use the column common_NA and the spectral color ramp and click Classify. Then click OK. Time for a question. What's the potential issue with the classification of data? If we look at the results, we'll see that arum lily's got a full stop after one of them, and there's some typos in variegated thistle, which means that they get classified repeatedly. So we're going to need to change the incorrect attribute values in the table to fix up this classification. This ensures all our attributes are standardized, which is essential for manipulating, filtering and mapping our data, and we'll learn more about these techniques later on in the training. So firstly, review your map canvas and find the location of the incorrect values based on your color classification. Right-click on the weed points layer and click Open Attributes Table. Click on Toggle Editing Mode in the Attributes Table toolbar. This will activate some of the buttons that were previously greyed out. Your table of contents will now show your weed points layer with the editing pencil next to it. Click the Common Name field heading to sort the data and search for Arum Lily. There'll be 2 of them, don't forget. Then double click on the value Arum Lily with the full stop at the end. And when the text turns blue, delete the full stop at the end of the name so the new value is simply Arum Lily. Just as a note, if your amendments are not showing up in the table after editing the values, refresh the field by clicking on the field name twice. Click the Save Edits button. Then repeat this process and change variegated thistle with the double E and with no I to the correct spelling. Then click off the Toggle Editing Mode in the Attribute Table toolbar and click Save and close the attribute table. Now review your map again. The incorrect values should now be coloured correctly in the map, but not the classification to the left under Layers. To correct the classification of the weed point data in your table of contents, right-click on the weed point layer, click Properties, then Style, and click Delete All to remove all the values. We're going to reclassify them now, so click Classify to reclassify your data with the new amendments, and click OK. You'll now see only 2 entries for the species as there are no spelling errors. That's what we want. Now that we can see the weed locations, we can check the accuracy of their spatial location. For this project, let's say there's an old weed point that should be removed, located above the Karakarup Nature Reserve. We're able to do this within the workspace by clicking on the weed points layer to activate it, and then in the top toolbar, change the Select Features by Freehand to Select Features. Click on the point just above Karakarup Nature Reserve so it changes to a different colour. Maybe a bit difficult to see the colour change depending on your settings. Then right-click the weed point layer and click Open Attributes Table. Resize the attribute table so you can see both the map and the attributes. The selected location should be highlighted in the attribute table. Click on Toggle Editing Mode and then click Delete Selected Features. In the map, the point will now be deleted. Click Save Edits. While we're editing the attribute table, we'll add a field for additional information. Select New Field in the toolbar, that's this icon here, and fill out the following details. For name, we're going to do coll date or collection date, so COLL_date. And for comment, put date sample collected. And for type, put date, then click OK. Add another field as follows. For name, we want comments. For comment, we'll put comments about the survey. The type is going to be text and the length is 254 characters. Click OK and click Save Edits. Note the different type options for spatial data are whole number, integer, decimal number, real, text, string, and date. Alternatively, you can delete unnecessary fields. In this case, we want to delete the projection details as it's already automatically saved as part of the shapefile. Select Delete Field, and then select Projection from the list, and click OK. The field should now be deleted. Click Save Edits. Time for a question. What's the shortcut syntax to the Delete Field tool? You can hover over the tool to find this. Manual data editing works well, but it's time-consuming if there's numerous features in a dataset. However, QGIS allows you to automate multiple field entries using the field calculator. So let's click on Open Field Calculator. Using the field calculator, we'll automatically fill the coll date field in our attribute table. This field indicates the collection date of our species. So let's activate the Update Existing Field box, and below it select the coal date field. In the expression box, type single quote 2014-02-02 single quote. So the dates have to use this format to be valid in QGIS. If the expression is invalid, an expression is invalid error message will appear, and if it's valid, you should see the date value entered in the output preview. Note that single quotes are required in expressions to tell QGIS that you're dealing with strings, date, or text. Numbers don't actually require any quotes. Date fields require the format year, month, day. Click OK and click Save Edits. In your attribute table, all records in the coal date field should now be automatically updated with the value 2014-02-02. If we want to update fields based on a selection, we need to specify this in the expression. So in this case, we want to add that Mr. Peabody recorded all the variegated thistle locations. In the attribute table, highlight all the values of variegated thistle, and as a hint, you can highlight multiple rows by holding down the Control key and clicking on the row IDs on the left. Click Open Field Calculator. Ensure Only Update X Selected Features is activated. Activate the Update Existing Fields box and choose Recorder. In the expression box, type p.peabody, including the single quotes, and check that the expression is valid, then click OK. Click Ctrl+S on your keyboard to save your edits. The Recorder field will now be updated with the new text. Selecting features one by one can be time-consuming, so QGIS gives you the option of selecting multiple features via an expression. Firstly, clear your attribute table selections by clicking the Unselect All button or Ctrl+U. Click on the Select Features by using an expression button. This will bring up the Select by Expression window. Then under the search box, click on the small cross to the left of the Fields and Values listing, and this will show all the field names currently found in your attribute table. Double-click on the species name to bring up the expression box. Under Expression, click on the equals sign. The value in the expression box should look like mine now. Next to Load Values on the bottom right, click All Unique. The unique values of that field will appear. Double-click Syllabum Marianum to add it to your expression. The expression box should now have text that looks like mine. Note the different use of double and single quotes in an expression. Click Select, then Close. All the rows with the species name Syllabum Marianum should now be selected. So amend the comments field using the field calculator. Click Ctrl+I on your keyboard. Activate Update Existing Field and choose Comments. Add the text to the expression box. Requires further ground truthing. Check the expression is valid and click OK. To unselect all the rows, click Deselect All and click Save Edits. You can also add an expression straight in the attribute table as a shortcut for simple tasks. From the drop-down list, at the top left of your attribute table, select Coal Date, type quote 2014-0303 quote in the text box next to the sum icon and click Update All. The coal date field will now be updated. Click off Toggle Editing Mode in the attribute table toolbar and click Save and close the attribute table. Note the variety of functions you can use in the field calculator querying expressions are extensive. A basic list can be found on the QGIS website, which I'll link in the description box. Operators can be used extensively to manipulate data. The more common ones for text fields are AND, which selects one type and another type, OR, which selects one type or another type. We use IN for a list of values. This one concatenates string data. Like selects types based on string structure and wildcards, and Not selects everything except a type. Now we're going to practice some more with selecting records based on an expression. Click on Add Vector Layer and under Source click Browse. Go to your 01 Training Data 01 Shapefiles additional folder and choose testexpression.shp. Click Open and Open again to add the layer to your workspace. Open the Attribute table. Click on the Select Features by using an expression button. Arrange the Select by Expression tool and the Attribute table so you can see both. Now use the Select by Expression tool to work out answers to the following questions. For example, and note there's often more than one way to use operators. Let's go select ID1 and ID4. So we would type ID in double quotes equals 1 or ID in double quotes equals 4. If we wanted to select all sites except site D, we would type not location equals site D. Just pay attention to the different quotation marks used there. Complete the following based on your own expressions, then count how many rows the expression selects. Select all the recorders whose name is p.joe. Select sites A and sites B. Select site B, who was recorded by S. Smith. Select sites with an amount more than 1. You can also use the greater than operator. Select weed C and site C. Select all the weeds except weed C. Select all weeds that were recorded by the Smith brothers. Select all site A's that were recorded in May. These basic expressions or queries open up a large amount of functionality in any GIS system, so they're worth remembering. They can also be used to filter features within a map, populate fields in an attribute table, and label features by an expression. If you want the answers to the above, you can find them at the end of your manual. Close the Select by Expression tool and the attribute table, and remove the test expression layer from your workspace as it's no longer required. Save and close your workspace. That's the end of exercise 4. Hopefully you're now familiar with importing points and amending attributes. Head to exercise 5 to look at creating, modifying and joining data. Thanks for watching.